In this video, we're going to talk about how to solve a system of equations, specifically linear in our case, by graphing. In this first example, they want us to solve this system of equations by graphing. So eventually, we're going to learn how to solve by graphing, using substitution, and using elimination. So we'll have three methods. And eventually, we want to be able to determine when is it most effective to use each of our methods. So right away, when I'm given a system that has equations both in slope-intercept form, especially when I see fractions or really if I see a fraction, it's a little bit easier to graph this than it might be to solve it algebraically. The cool thing about systems is that you can solve every single system using any of our methods. It just might be a little bit more difficult to solve using a certain method over another. So in this example, because they're both in slope-intercept form already, we're just going to solve by graphing. So in order to do that, we're going to graph each equation to begin with. So in our first equation, we need to identify our y-intercept, which is always our b value, so 0, negative 1. And then we also need to identify our slope. The slope, in this case, is 1 over 1. So once we know this information, basically we're just going to go ahead and start graphing. So I'm going to plot a y-intercept at negative 1. And I'm going to use my slope, which is my change in y over change in x, to find some other points on my graph. So we're going to go up 1 over 1, put a point, up 1 over 1, and so on. Now I know in the past when we were graphing, we could just put a few points on our graph and then that would be enough. But because we need to solve this system, we need to be really precise in our graphing. So I'm going to connect my points all the way across the graph. So there's line 1. So now we're going to do the same thing, but we're going to graph equation 2. So this time, again, it's our b value, so our y-intercept is 0, positive 1, and our slope is 3/4. So starting at positive 1, 0, positive 1, I'm going to rise 3, so 1, 2, 3 over 4. 1, 2, 3, 4, and put a point. I'm going to keep doing this. I'm going to go backwards some to get a good line. And then I'm going to connect these points as precisely as I can. So in the last video, we talked about how the solution to a system of equations is the ordered pair that satisfies all equations in our system. In other words, it's the point that's a solution to both of them. Well, when I'm looking at a graph, the only spot on this graph where my two lines have the exact same point is this point of intersection right here. So when we are solving a system by graphing, we are looking for the point of intersection. Okay, where do my two lines meet? Because that's going to be where we have an xy pair that satisfies both equations. In this case, that's at 8, 7. Okay, so that's where our solution is. So we can actually check this algebraically, doing what we did in the last video by substituting these values back in. So to equation 1, if I put a 7 in for y and 8 in for x, I get 7 equals 7. So that works. So I'm showing you algebraically that you do get a true statement. Same thing for our second equation. 7 equals 3/4 times 8. Plus 1, well, 3/4 times 8 is 6. 6 plus 1 is 7. So again, this ordered pair is a solution to both of these equations, making it a solution to the system. And that point on our graph is always that point of intersection. So let's kind of summarize this with some steps. So in general, the first thing that you're going to do is graph both equations. Now this takes some previous knowledge, right? So we have to know how to graph an equation, really in any form. So that means I might need to put it in slope-intercept form, identifying my y-intercept, my slope, things of that nature, things we've done in the past. But once we graph both lines, we are trying to find the point of intersection. I want to know, where do these two graphs cross one another? And this is where our solution is. Once we have that, we can always check by substituting those values back in. So this is how we graph or solve a system by graphing.